So in this first section of functions, what I really want to cover is what is a function and how we can determine if something is a function based on mapping diagrams or coordinates or a graph that we're given. Now, if you're comfortable with the definition of a function, the definition of a relation, inputs, outputs, the independent variable, dependent variable, then you can skip ahead. I put the link in the description with a little timestamp that'll skip ahead to the actual determining if something is a function. But if you're not comfortable with that, just listen up and take notes on this part, because this is actually very, very important. Basically, in a nutshell, a relation is any set of inputs and outputs. For our purposes in Algebra 2, almost all the time the x values are going to be the inputs, the y values will be the outputs if we're talking about a set of coordinates. So if I had given you just a completely random coordinate, let's say we had 0, oops, I'm still in rectangle mode. Let's try that again. Let's say we had 0, comma 1. That's a 0. And we have our input would be 0, our output would be 1. Now, any set of coordinates that I give you, that's a relation. Okay, so I could give you 0, 1, and I could give you a set that also includes 2, comma 3. If these are both in the same set, that's a relation. Okay, there's no special relationship between them that we know of. It's just a relation. I want you to imagine it's just any set of inputs and outputs. So you can think of it now as any set of x and y coordinates. Okay, now the special part comes from a function. A function is a relation. Okay, that's something that's really important. You may see that every single function is a relation, but not vice versa. Not every relation is a function, but every function is a relation where every single input gives you only one output. I outlined that, capitalized it, yelled at you for it, because that's the important part of what defines a function. It's just a relation where every input gives us only one unique output. Okay, and we'll talk more about that in a second. But for these relations, the input we call the independent variable. So think of like input, independent. The output is the dependent variable. The output depends on whatever the value of the input variable is. So for example, you guys may have seen something like this previously. This is just a simple linear function that we'll talk about in more depth soon. But if you can tell, it's not so obvious what's the dependent, what's the independent, but what I will tell you as a shortcut is look for the variable that's by itself. That's generally the dependent variable. Y completely depends on whatever x is. If x is 0, 2 times 0 minus 2, then y is negative 2. If x is 1, then 2 times 1 minus 2, that's 0. So y depends on x. X is the independent variable. Y is the dependent variable. So if you want to think of it again, the independent variable is the input, the dependent variable is the output. Okay, so that's a whole lot to cover in just one what's it been, like 3 minutes? But that's really what a relation, what a function is. The functions are what we were going to be talking about for the rest of algebra. So just be comfortable in the fact that every single function, each input only gives me one output, always. So now let's go on to how we can actually determine, based on the different methods that you'll see in class, whether something is a function or not. So really there's 3 different methods. I don't know if you can see this. I made it a little bit small, it looks like. 3 big methods that you look at when looking to see if something is a function. Either you'll get a set of coordinate points, you might get what's called a mapping diagram, or they'll just give you a graph and say, okay, they can give you either one of those 3 and say, okay, is this a function or not? What you need to look at in this particular case, let's look at the coordinate points. Remember, the x coordinates are the inputs. What I want you to look at is, does each input give me only one output? I only see 1, 0 input here, and it only gives me one output. I only see one, x equals 1. I only see that one time, so it only gives me one output. I only see x being 2 one time. That only gives me one output. Now, if I had put something in here like 2, comma 5, if you notice, now we've got 2 inputs that are equal to 2, but they give us 2 different outputs. That's not a function. That's a relation, but that's not a function. Okay, that violates the idea that every single input gives me only one output. Okay, the same idea of a mapping diagram. You could think of these as the easiest way to look at this is to see that, and I'll zoom in on this a little bit. Think of the input again, same thing. The input's basically x. The output is basically y. All right. Now, in the future, we'll use different variables. We'll use t for time for the input, but we're not there yet. For our purposes, x and y are going to be our main variables. So if you look, this looks very similar to this, to the coordinate points, in that this input gives me one output. So this x value gives me one y value. This x value gives me one y value, or input gives me output. So this input gives me one output. Now, again, what I was getting at before, you could think of this as like 3, 1. If I had to put that in a coordinate point, 3, 1, this would be 4, 6, this would be 5, 8. So they're very similar to coordinate points. It's just another way to look at them individually. But what happens, again, if I throw some random extra arrow in here, look at what happens if I draw another arrow from 3, let's say it's going down to 6. That means my input 3 could give me an output of 1, but it also could give me the output of 6. That's a problem. That's not a function. Okay, remember, these questions are generally asking you, hey, does this represent a function? Does this particular mapping diagram represent a function? In this case, because of this new arrow that I drew, no, that's not a function. The input could give me 1, but it could give me 6. That's not a function. It's a relation, right? But it's not a function. Every single input can give me only one output. But again, as it was before I put that extra arrow in, this is a function. That's perfectly fine. My circles are not coming out right, but that's a function right there. Okay, now that's a mapping diagram. That's what that calls it. It maps the input to the output. That's what it means. The third one, I realize all this stuff is kind of jumbled together. I apologize for the ugliness of it, but now they'll give you a graph. And they'll tell you, okay, does this represent a function? This is where you've probably learned it before. You've probably heard of it. This is called the vertical line test. Okay, where basically, and if this was actually in person, you would have like a pencil. This is how we were taught back in the day. Imagine putting your pencil. I'm going to draw a straight line here. Let me lock this function in place. I'm going to draw a straight line. Let's call it right here. Imagine that's your pencil. And the vertical line test says if I move this pencil at any particular point, if at any x value it crosses more than one y value, boom, it's not a function. Okay, it fails the vertical line test. But if you look here, every single x value only gives me one y value. Okay, so this is a function. But if I put, again, just to show you what happens if it's not, let's say I put a point right here at x equals whatever that is. I can't think of that off the top of my head. That looks right at that point. If you notice, when I move this, again, this is particularly a pencil, but it's a line. If I go, everything looks good. You know, we're only, for every single x value, we've got one y value right here. It doesn't really look like it's perfect, but right at that particular x coordinate, is it here? Is the output giving me this, or is the output giving me this? That's a problem. That fails the vertical line test. So you see how just one point can throw off the entire, what would be a function. Now again, it's still a relation, but this, as I drew it, with this extra little point up here, that's not a function, okay? So that's what it means. And you'll see weird looking graphs, and we'll do one in the next example. So that's pretty much it in a nutshell for the three different main ways of how they'll ask you to determine if something is a function. We've got, let me move out a little bit. We've got coordinate points, we've got mapping diagrams, and we've got graphs. Okay, so let's take a look at another example of each. And let me space these out a little bit better so they zoom right in. So look at these set of coordinate points right here. I'm looking here and I see, okay, we've got an input of 2, that gives me 5 for an output. That's fine. I've got an input of 3, it gives me an output of 6. Okay, cool. But I've got another input of 3, and it's not 6, that's the output. So I've got 2 inputs of 3 giving me 2 different outputs. That's not a function. Okay, that's a relation, but that's not a function. I can't be getting 2 outputs for 1 input. Okay. If we look at a mapping diagram, if you look right here, try this one out. Let me actually center this a bit. If you look at the arrows, okay, we've got an input of 0. So basically think of this as x, this is y, if they were coordinates. 0 gives me 5, that's cool. 5 gives me 5, that's okay. But 5 also could give me 8, right? That's a problem. That's not a function. I've got one input value giving me 2 different output values. And it could be more than 2. It could be like 3 or 5 or a million. It doesn't matter. If it's more than one output that you're getting for one input, then that's not a function. Whatever is being represented is not a function. Again, it's a relation, but it's not a function. Now, if you take a look at this weird looking graph, let's do the vertical line test on this. And again, the vertical line test, we pretend we have like a little, literally a vertical line, and you want to move it over the curve. If it crosses at more than one y value for any x value, it fails. So if you look right here, this particular one, at this x value that I just randomly, it looks like it's x equals 2 that I chose. Y could be this or y could be this. We've got two different y values. Remember, the y is the output. So when x equals 2, is y equal to positive 2 or is y equal to negative 2? That's not a function. We can't have that because we're getting two different outputs for one given input. And if you actually look, this pretty much fails at every single point. Every single point that I could draw on, I get two different outputs. Okay, so that's what that looks like. So you'll see random ones that, this graph, you'll see a graph that looks like this, like an S, that fails pretty much everywhere too. Money sign, anyway. But that's in a nutshell pretty much how we look at different variations of determining whether something is a function. They'll give you graphs, they'll give you these mapping diagrams, and then they'll give you just a straight up set of coordinate points, nothing else. They'll give you a set of coordinate points and ask you, do these points represent a function? And it all boils down to, does each input give me one and only one output? If so, that's a function, whatever it represents. Okay, that's a function. So hopefully this video was helpful. I'll put a link in the description again with a couple of more examples, because this is kind of tricky, determining, okay, is it a function, is it a relation? And there's three different types of ways that we can look at it. So getting some extra practice with this is essential. You want to make sure you see multiple variations of this and what they might ask. So take a look at the description. I'll have some practice problems for you to look at and work through those, and then the solutions will be on the website as well. So hopefully, again, this video helped, and we'll see you in the next one.